So revisiting elements and compounds. So here we have pure substances. Pure substances can be elements or they can be compounds. In a pure substance, all of the individual particles are the same. In an element, all of those particles only contain atoms of the same element. In a compound, like this compound here, water, each of the molecules is the same, but a single molecule has more than one kind of atom in it. And so that makes this a compound. Over here with the elements, we could have single atoms, or we can have molecules composed of two or more atoms of the same element. So this is O2. O2 forms molecules. Each molecule is two oxygen atoms covalently bonded together. You might wonder, well, why does oxygen do that and neon doesn't do that? We'll learn about that. Probably more than you'd like to. So these are atomic elements. The individual particles are atoms. Molecular elements have molecules, but the molecules contain atoms of only one element. Over here with the compounds, we have molecular compounds and ionic compounds. Molecular compounds contain molecules. Ionic compounds contain ions. So in something like sodium chloride, we can represent the formula as NaCl, and that represents the ratio of sodium ions to chloride ions. For every sodium ion, there's a chlorine ion, because that's how the charges work out. This overall substance has to be neutral. We can think about a formula unit, which is a unit that's represented by the formula, 1 sodium and 1 chlorine, but there are not individual molecules in an ionic compound. This is just a series of alternating ions. And so you can't say, well, there's 5 molecules of sodium chloride. We can call them formula units, but they aren't actual molecules. Yeah? Yes. Yeah, this is a pure substance because the ratio of chlorine to sodium is always the same. So going through that flow chart with a bunch of words on PowerPoint slides. We have atomic elements where they exist as single atoms as their basic unit. And this is most elements. And then we have molecular elements, and these contain 2 or more atoms of the same element bonded together. And there are 7 of these that are diatomic. The prefix di means 2 atoms. So they're 2 atom molecules. And then there's some that form polyatomic element or polyatomic molecules. They have more than 2. Examples are P4 and S8. These guys are kind of weird. We should know that they happen, but we don't need to remember them. These guys we need to know. So here's a periodic table. Here's hydrogen in the yellow are diatomic. Hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. These all form diatomic molecules. So when we write the formula for these elements, it's N2 or F2, because when they are alone, they form molecules. So I've turned these elements in my mind. I have this place, I call it Mrs. K's Chemistry Land. It's a happy place for me. It might not be happy for other people, but it's my place. I think of the nonmetals as being feminine. The metals are masculine. So metals, masculine. Nonmetals, non-masculine, right? Because there's 2 kinds. There's positive and negative ions. So I think of these females here as being like junior high girls. I don't know if you remember back to junior high. Junior high girls don't go anywhere by themselves. They travel in pairs or in packs, right? This was pointed out to me when I was a junior high girl, and I was really just sort of dismayed to find out that it was true. If I needed to use the bathroom at school, I went with a friend. I don't know, it's just a thing. These atoms are never by themselves. You think of it as the buddy system. Okay, so if nitrogen is going to go out, it's going to take another nitrogen atom with it, and they're going to go together. Oxygen, fluorine, these all do that. And then there's hydrogen over here, and hydrogen just kind of does what he wants to do, but he's also one of those groups. So there's a couple of different ways to remember what's going on here. So if we start at element number 7 and make a 7, those are diatomic elements, and then of course hydrogen, because he's got to be an exception to everything, right? The other way we can do this is with a mnemonic, which is a sentence that starts with useful letters that spell something. So let me make space for my sentence. Getting rid of that. Horses need oats for clear brown. It's going so well. Eyes. Oh, wait a minute. Eyes. Horses need oats for clear brown eyes. Hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine. It's a bit of a stretch. Iodine. Okay. It is important to know those. Any questions? These other guys here, phosphorus, sulfur, selenium, those can exist as polyatomic molecules, but for Chem 1A, you don't need to remember that. Molecular compounds are usually composed of 2 or more covalently bonded nonmetals. The basic units are molecules with the constituent atoms. So water contains H2O molecules, and this represents what's in one molecule, 1 oxygen, 2 hydrogens. Dry ice is CO2, there's 1 carbon and 2 oxygens. Propane has 3 hydrogens and 3 carbons, trying to make sure you're paying attention. 3 carbons, 8 hydrogens. So we could represent these in a space-filling model as these funny-looking things. These are independent particles that move around. Okay? Each of these particles has 3 carbon atoms and 8 hydrogen atoms. Each of the molecules is the same as the other molecules. It's not a mixture. There's a fixed ratio, and all the particles are the same. Ionic compounds are composed of cations and anions. The cations are usually a metal, and the anions are usually nonmetal. And so this is like males and females, and the positive ion is attracted to the negative ion. Okay, so this is just very stereotypical stuff. This is not a reflection on anything else. This is just an example to help us remember. Okay. The basic unit here is called the formula unit, the smallest electrically neutral collection. And it's usually the empirical formula. So again, looking at table salt, we have alternating sodium and chloride ions. There are not individual particles. Okay. We can also have polyatomic ions. So a polyatomic ion is an ion that contains 2 or more atoms. So if we look at these examples, NaNO3, this has a sodium ion, that's the metal cation, and then the rest of it together is 1 ion. Do you remember what its name is? Nitrate. That was on the memorization stuff. Nitrate, NO3. How do we know that nitrate is NO3 minus? We remember. We memorize it. It's just like, how do you know that this is a letter A? Well, they taught you that in kindergarten, right? Just because. calcium carbonate, calcium ion, and a carbonate ion. KClO. So here we got 3 different elements. It's potassium ion, and this is hypochlorite ion. So when we look at these formulas, how do we know where to divide them? How do we know how many ions are present? Well, in Chem 1A, we can avoid some of the more complicated things. In Chem 1A, ionic compounds always have 2 ions, 1 cation and 1 anion. And so I look at this formula, and the first element is a metal. That's the guy. That's the positive ion. And the rest of this, cover up him, the rest of that together is 1 ion. So this is where the analogy gets a little weird, because is that 4 girls together with the 1 guy? Yeah, well, we can't take it too far. Okay? But there's always 2 ions. They have to have opposite charges or they won't attract each other. Okay, we should be able to classify substances, and here we're asked to use atomic element, molecular compound, or ionic compound. So fluorine, first of all, is that an element or a compound? It's an element. Is it atomic or molecular? Well, is it one of the 7? Yeah, it is. So that means it's molecular. This is a molecular element. It's present as F2. If I wrote F2, then it would kind of give it away. That's why we use the name fluorine instead. How about N2O? Is that a compound or an element? It's a compound. The clue there is there are 2 capital letters. Each element has a capital letter. So this is a compound. Is it molecular or ionic? It's molecular. How do we know? There's no metals. So we have 2 nonmetals. In order for it to be ionic, we'd have to have a positive and a negative. And these are both nonmetals. Nobody wants to give up an electron. So this is molecular. How about silver? It's an atomic element. So silver, you can find silver on the periodic table. It's one of the ones I asked you to memorize. And it's not one of the 7 diatomic elements, so it's atomic. How about K2O? That's an ionic compound. Ick. We know because potassium is a metal. Now, you might not recognize potassium as a metal because we think of something that's something we need in our diets. It's found in bananas, and the last banana I ate did not have chunks of potassium in it, right? But on the periodic table, where is potassium? It's way on the left side. It's in the metals section. So here I have a metal and a non-metal ionic compound. How about this one down here? Is Fe a metal? Yep. Is O a non-metal? Yep. Metal, non-metal, ionic compound. Any questions? Being able to identify molecular versus ionic is the first step in being able to write names and formulas.